You know, when you think about medical breakthroughs, your mind probably jumps to flashy new drugs or maybe those amazing surgical robots, right? But today we're diving into a different kind of revolution. This one's a lot quieter, happening behind the scenes, in lines of intelligent code, and it's completely changing how doctors see and heal the human body.
And that quote just nails it, doesn't it? The really profound changes, the ones that shift everything, they often don't make a lot of noise. And that's exactly what's happening here. This revolution is taking place on computer screens and planning rooms, and yeah, in operating theaters. And it's making surgery safer and more precise than we could have ever imagined.
So let's think about this for a second. How do surgeons navigate the most complex terrain imaginable? I mean, the human body, it's this incredibly intricate three-dimensional world. And for a surgeon, especially a neurosurgeon, finding your way around in there has always required this almost superhuman level of spatial awareness. But here's the big question. What if they had a better map?
All right, so here's how we're going to break it down. First, we'll look at the big problems surgeons have been up against for ages. Then we'll get into the tech that's basically Google Maps for anatomy. We'll see how it works, what it means for real people, and then we'll peek into the future to see where this is all going.
Okay, so first things first, we really need to get our heads around the fundamental problem this technology is built to solve. For decades, surgeons have been looking at flat, two-dimensional images, CT scans, MRIs, and trying to use them to plan these unbelievably complex procedures inside a three-dimensional person.
And this analogy, it's perfect. It's like trying to fold a paper map into a globe. Seriously, just picture that for a second. Taking dozens of flat slices and having to build a perfect 3D model of an organ in your head. That's what surgeons have been doing for years. It's an incredible skill for sure, but it's also just massively, massively demanding. And this slide really lays out the before and after. Back then, it was this intense mental puzzle. Today, well, now the software does all that heavy lifting. It takes all those different images and automatically stitches them together into one single, accurate, and totally interactive 3D model.
So what is this magic software that's pulling all this off? Well, let's introduce the solution. It's a suite of tools from a German company called Brainlab, and the software itself is called Brainlab Elements.
And the key thing to understand here is that Elements isn't just some fancy image viewer. No, it's an intelligent platform. It's designed to take all that raw, complicated data from CT scans and MRIs and transform it into a super intuitive, dynamic map of that specific patient's body.
And there it is, the metaphor that just makes it all make sense. It's like Google Maps for the human body. Just think about it, right? Google Maps gives you satellite views, street views, tells you about traffic, finds the best route. This software does exactly that, but for a surgeon. The destination is a tumor, the highways are blood vessels, and the no-go zones are critical nerves.
And if you want to know why this matters so much, get this. In brain surgery, a tiny shift of just 2 millimeters can be the difference between a safe procedure and damaging vital functions. We are talking about the ability to speak, to move, to see. So this kind of GPS-level precision, it's not just a nice to have, it's an absolute game changer.
Okay, so how does it actually do all this? Well, Brainlab Elements isn't just one single program. Think of it more like a digital toolkit with a bunch of different specialized modules, and each one is designed to solve a very specific problem. Let's look at 4 key examples from that toolkit. You've got Cranial Planning, which helps surgeons map out the safest possible route to a tumor. Then there's Fibertracking, which is incredible. It lets them actually see the brain's unique wiring. The Multiple Brain Metastases module automates a process that used to take forever, and the spine modules, they bring that same level of crystal clear detail to the super delicate area around the spinal cord. Okay, I have to talk a little more about this Fibertracking module because it's just so powerful. It actually visualizes the brain's neural highways. Using a special kind of MRI, it maps out the brain's entire communication network. So for the very first time, a surgeon can look and see the exact pathways that control a patient's speech or their movement, and then plan the surgery specifically to protect them. It's literally a personalized roadmap for every single brain.
And talk about efficiency. This is huge. For a patient with multiple brain tumors, doctors used to have to sit down and create a separate, complex radiation plan for every single one. That could take an entire afternoon. Now, the software can whip up a single coordinated plan in just minutes. That frees up doctors to spend less time on a computer and more time focusing on the patient, which is, the whole point.
All right, so we've geeked out on the tech, but what does all this actually mean for doctors and for patients on the ground? This is where it gets really interesting, where we see this perfect blend of human skill and digital intelligence making a real, tangible difference.
Just look at this number, 23 million. That's how many neurosurgical procedures are needed worldwide every single year. The sheer scale of that need is just staggering. So you can imagine, any tool that makes these incredibly high-stakes procedures safer and more accessible is going to have a massive global impact.
And this brings up a really important point, that whole fear of AI coming in and replacing doctors. But that is not what's happening here. The software doesn't decide, it assists. It's a collaborator. It serves up the data, it highlights the risks. But the final call, the critical decisions, those are still made by the human surgeon, 100%.
A great way to think about it is like an artist with a new digital brush. The tool opens up new possibilities, lets them create in ways they couldn't before, but it doesn't replace their creativity or their judgment. It's the exact same idea here. This software is a tool that enhances a surgeon's skill, amplifying their talent and experience by giving them this unbelievable new level of vision.
And check this out. This chart shows another huge benefit, and it's all about democratizing care. By automating a ton of the planning work, you can slash that planning time by up to 80%. And what does that mean? It means these super advanced treatments aren't just for the biggest, fanciest hospitals anymore. Smaller clinics can now offer that same high level of care to way more people.
Okay, so what's next? Where does all this lead? Well, this software is really just the foundation for a much more integrated future. It's taking us into what people are starting to call the augmented surgeon era.
The next big leap is going to come from mashing this incredible mapping software with other bleeding-edge tech. We're talking deeper AI that can predict outcomes, cloud computing so surgeons can collaborate from anywhere on the planet, and this is the really cool one, mixed reality, to put that digital map right in front of the surgeon's eyes.
I mean, just imagine this for a second. A surgeon's in the OR, they're wearing a pair of AR glasses, and as they look at the patient, they see a floating, translucent 3D hologram of that person's brain, perfectly overlaid on their body. The tumor is glowing, the critical nerve pathways are lit up, and it's all updating in real time. The line between the digital plan and the physical world just evaporates. That's the future we're heading towards.
And that really brings us to a final, pretty profound question. If you think about it, the 20th century was the age of antibiotics, right? They changed medicine by fighting disease from the inside. So, is the 21st century going to be the age of algorithms? Are they the things that are revolutionizing medicine now by giving us this unbelievable power to see and plan and act with incredible precision from the outside? It's a quiet revolution for sure, but I think its impact is only just beginning.